Have you ever stopped to think how something that costs less than a soda can cook an entire meal? No gas, no electricity, no advanced technology, just a can. Now imagine this. You're in the middle of nowhere, no stove, no power, nothing. And even so, within minutes, the water starts to boil. It looks like magic, but it's not. It's a design so simple, it gets ignored. So cheap, no one takes it seriously. And so efficient, it raises an uncomfortable question. Why is almost no one using this? There's an old version of this can stove that already works incredibly well, but there's also an upgraded version, more powerful, more stable, and almost unknown. And today, you're going to understand exactly how this works, why this method was left behind, and how you can build your own with almost nothing. By the end of this video, you'll never look at a simple can the same way again. Long before the idea of modern survival became a trend, simple solutions were already being used far from the public eye. In 1978, in a small fictional coastal village called San Elmo del Sur, a mechanic named Raul Ortega faced a common problem: expensive fuel and food that needed to be cooked every day. Without consistent access to gas, he began testing alternatives: candles, alcohol, leftover oil. Nothing seemed efficient enough. Until one day, he did something unusual. He took 2 discarded cans, cut them, fitted one inside the other, made small holes around the edge, and poured a bit of alcohol inside. When he lit it, something unexpected happened. The flame didn't stay only in the center. It started coming out through the small holes, forming a uniform ring of fire, almost like a real stove. Without realizing it, Raul had recreated, in an improvised way, a principle that already existed in isolated scientific experiments: pressurized vapor combustion. But there, it wasn't theory. It was survival. For months, he refined the model, adjusted the size of the holes, tested different fuels, and the most impressive part, he managed to boil water faster than much larger improvised stoves. The story never became a headline. It was never patented. It never went into production. But stories like this began to appear in different places, with different people, always arriving at the same solution: a powerful stove, hidden inside something everyone throws away. And the most intriguing part? The version most people know today is not the most efficient one. There's an evolution of this design that almost no one talks about. And that's where things start to get even more interesting. This can stove works on a basic principle of physics, turning liquid into vapor, and using that vapor as pressurized fuel. Think about it like this. When you pour alcohol into the can and light it, the initial flame heats up the metal itself. That heat starts to evaporate the alcohol. And this is where everything changes, because vapor, unlike liquid, spreads quickly and wants to escape, but it finds a specific exit: the small holes around the can. The result? The vapor shoots out at high speed, and when it comes into contact with the flame, it burns in a continuous and uniform way. It's no longer just any flame, it's a pressurized ring of fire. Now compare that to a regular stove. A gas stove mixes air and fuel before combustion. Here, you create the same effect, but by recycling heat from the flame itself. It's an intelligent cycle. You light it, it generates heat. The heat creates vapor. The vapor feeds the flame. The flame generates even more heat, a self-reinforcing system. And there's more. The temperature can easily exceed 500 degrees in the combustion zone, depending on the fuel. That's more than enough to boil water in just a few minutes, cook simple meals, heat metal surfaces quickly. Now here's the difference almost no one notices. The old version of this stove loses heat through the sides. The upgraded version controls airflow better and reuses even more energy. It's like comparing an open campfire versus a concentrated blowtorch. Same idea, completely different efficiency. And the most absurd part, all of this, coming from a simple can, something that would normally take less than 3 seconds to throw away. But if this is so efficient, Why have you never seen it used on a large scale? That's exactly where the story starts to get strange. Now think carefully. If something is too cheap, too simple, and still works well, why didn't it become the standard? A regular stove creates dependency. Gas, energy, refills, brands, constant consumption. But this stove doesn't need any of that. You build it once and keep using it without having to buy almost anything afterward. And that's where it stops being interesting for any industry, because it doesn't generate money, it doesn't create a consumption habit, it doesn't lock the user into anything. And when a solution doesn't create a market, it simply doesn't get space. But there's another detail that few people notice. The version that's spread around, the simpler one, does work, yes, but it's not the best. It loses heat, uses more fuel, and takes longer than it should. Meanwhile, there's an upgraded version. More stable, more efficient, smarter in how it uses heat. But almost no one talks about it. Not because it's difficult, but because no one had a reason to promote it. Knowledge stopped at good enough. And when something already solves the problem, most people don't keep improving it. The result? You know a basic version, but there's a much better one, almost hidden. And that's exactly what you're about to see now, in practice. Now let's move away from theory and go straight into practice, because this is where everything changes. You don't need expensive tools, no experience, not much time. Just attention. You'll need 2 aluminum cans, soda, a utility knife or blade, something sharp, needle nail, some alcohol, ethanol or 70% plus. Now the process: first, cut both cans at the bottom, about 3 to 4 centimeters high. You'll end up with 2 bases. On one of them, make small holes around the upper edge. No need to overdo it. Around 10 to 16 holes already creates a good flow. Now fit one piece into the other, forming a single unit like a small closed container. Before sealing it completely, you can place a bit of cotton inside. This helps hold the fuel and stabilize the flame. Done. To use it, pour alcohol inside. Wait a few seconds for it to absorb. Light it from the center. In the first few seconds, the flame may look weak. But wait, the heat starts to rise, the alcohol evaporates, and suddenly, the flames begin to come out of the holes, forming that ring of fire. Now pay attention here, because this changes everything. The upgraded version doesn't rely only on the can, it controls the airflow. You'll basically add 2 things: an inner wall, made from a folded piece of aluminum, and a simple external support, like 3 screws, stones, or wire. What does this do? Improves internal pressurization, directs the vapor more efficiently, prevents lateral heat loss. Direct result: the flame becomes stronger, alcohol consumption decreases, cooking time drops. In practice, it's like going from an open flame to something much more concentrated. With the simple version, 500 ml of water may take around 7 to 9 minutes to boil. With the upgraded version, that can drop to around 4 to 6 minutes. Same amount of fuel, more efficiency. Important detail: always use it in a ventilated area. Avoid flammable surfaces and never refill while the stove is still hot. Simple, but it requires respect. And this is where many people realize you don't need a complicated setup or depend on anything external. When you understand the principle, you create your own solution. Now, look at what you've just seen, and try to compare it to what used to feel normal. A traditional stove depends on constant purchases, structure, specific fuel, and accumulated costs over time. Meanwhile, a simple discarded can, with a bit of alcohol, can generate a stable, hot, and functional flame. You saw that this isn't random improvisation. There's a clear principle behind it. Heat creating vapor, vapor feeding the flame itself. An intelligent cycle, simple and extremely efficient. And more than that, you understood that there are 2 levels. The basic one, which already works, and the upgraded one, which completely changes performance. Same idea, same material, completely different result. This breaks a belief many people carry without realizing it. The idea that something needs to be expensive, complex, or industrialized to work well, when in reality, many times, the most powerful solutions are the ones that go unnoticed because they are too simple to attract attention. And maybe that's the most important point of all. This isn't just about a can stove. It's about realizing how many solutions exist around you. Cheap, accessible, ignored, waiting for someone to look more closely. And now that you've seen this, it's hard to unsee it. Now it's up to you. You can simply close this video and keep seeing a can as trash. Or you can test it. Take 10 minutes, build yours, light it, and see with your own eyes something simple turn into something truly useful. Because knowledge like this only changes something when it leaves the screen and goes into practice. And there's more. If this kind of content makes you think differently, shows you uncommon solutions, and opens your mind to things almost no one talks about, then you already know what to do. Subscribe to the channel because here, the ordinary has no space. And share this video with someone who needs to see this too. Because sometimes, all it takes for someone to change the way they see the world is a simple idea at the right moment. And in the next video, there are more things like this, hidden in plain sight, just waiting for someone to notice.